Hello and welcome to all viewers of this session, in which I will take you through the formation and physiography of the majestic mountains. Mountains that cover 1/4 of the land surface of Earth and are home to about 12% of the global population. They are the source of the world's major rivers and provide around 70% of world's fresh water, affect regional weather patterns, provide biological and cultural diversity, hold deposits of minerals, and are major attractions for tourism. In this session, the objectives are to understand the definition of mountains, to learn about different types of mountains and how they were formed, to identify major mountains across the world, and to know different topographic landforms found in mountains. Finally, to have a look at importance of mountains for sustainability and tourism. Now, landform is a natural feature of the Earth's surface. The surface of the Earth varies from one place to another. Most geologists classify a mountain as a landform that rises at least 1,000 feet or 300 meters or more above its surrounding area. A mountain range is a series or chain of mountains that are close together. When an array of such ranges is linked together, it constitutes a mountain belt. A mountain belt in many tens to hundreds of kilometers wide and hundreds to thousands of kilometers long. Individual mountains are connected by ridges and separated by valleys. Within many mountain belts are plateaus which stand high but contain little relief. For example, the plateau of Tibet. Mountains make up 24% of the Earth's surface, where we find 53% of the surface of Asia covered by mountains, 58% in America, 25% in Europe, 17% in Australia, and lastly, the continent with the few mountains, Africa, with only 3% of its surface covered by mountain ranges. Let us take a look at the characteristics of mountains. A mountain rises prominently above its surrounding, generally exhibits steep slopes, has a relatively confined summit area, and with considerable local relief. A relief means the terrain of the earth and implies the difference between the highest and the lowest elevation of an area. I now take you forward to examine the different parts of a mountain. Mountains may seem to be a single landmass rising to the sky. However, there are different parts of the mountain, including valley. It's the land space that lies between two rising landscapes of the mountains. Foot. Foot of the mountain, also called the base of the mountain, is the broad structure from where the landmass begins to rise above. It's the lowest part of the mountain. A slope or skirt. The slanted part of the mountain that lies between the top and the foot of the mountain is called its slope. Top is the topmost part of the mountain, often steep and covered in snow. How mountains are formed is really interesting, and as a tourism professional, knowing these facts can add great impetus to your interactions with tourists. The process of mountain formation is called orogenesis. Depending upon the internal and external activities of Earth's crust, there are 5 types of mountains: folded mountains, fault block mountains, vault or dome mountains, volcanic mountains or mountains of accumulations, and the circumerosional or relict mountains. Let us together understand the process of mountain formation and also learn through examples a few names and locations of each type on the Earth. The first one is the original tectonic mountains constituting of 2 mountain types. These mountains are formed due to large-scale movements in the tectonic plates and the resulting in collision and folding of plates. These mountains are further classified into block mountains and fold mountains. Let us examine the block mountains first. Fault blocks mountains are formed when faults or fractures in the Earth's crust pushes rocks upwards and downwards, and a fault block is raised or tilted. In such a case, the Earth's crust does not fold, but it breaks or fractures. The resultant faults could move blocks of rocks upwards or downwards, creating summits and valleys. When blocks of rocks are pushed upwards, they are called horsts. These are higher blocks. Similarly, when the rocks are pushed downwards, they form throughs and they are called graben. An example of a graben is the basin of the Narmada river in India between the Vindhya and Satpura horsts. The movement of the Earth's crust along the fault often causes an earthquake in the adjacent areas. One significant characteristic of block fault mountain is their sloping rear and steep front. Two types of block mountains found on our planet are the lifted block mountains and tilted block mountains. Lifted block mountains are block mountains that have two very steep slopes and a broad top with clear horst and garden terrains. The example includes the Vosges mountain in France. Tilted block mountains are characterized by a gentle slope on one side and a steep slope on another side. These are common in the basin and range regions of the western United States. Let us examine the fold mountains. Fold mountains are formed due to large-scale collision of tectonic plates which result in subduction and folding. The process of folded mountain formation is called orogeny. It takes millions of years for orogeny process to create folded mountains. The region where the plates collide is known as continental collision zones or convergent plate boundaries. The plates push each other with such a force that the rocks and the boundaries fold and wrap, forming mountains. When folds are pushed downwards, they are called synclines. When folds are pushed upwards, they are known as anticlines. The folded mountains could continue rising as the tectonic plates keep pushing each other. The Himalayas, for example, are still rising. The majority of fold mountains are made up of sedimentary and metamorphic rocks that originated under high pressure and at low temperatures. Himalaya, Rockies, Andes, Balkan Mountains, Jura, Zagros mountains are some examples. There are mainly two types of fold mountains, young folded mountains and old folded mountains. Young folded mountains are those mountains that are around 10 to 20 million years old. They have a steep and sharp summit. The Himalayas are an example of a young folded mountain. Old folded mountains are those mountains that are more than 25 million years old. They have a broad summit due to the wear of Earth's geological activities. The Urals are an example of an old folded mountains. The third type of mountain is the dome mountain. Dome mountains do not involve the movement of tectonic plates. Instead, the movement of molten rocks or magma under the Earth's surface result in the formation of vault or dome mountains. They are formed when the hot molten material magma rising from the Earth's mantle into the crust makes its way upwards the surface and forces the top sedimentary rock layers upwards. Unlike a volcano, magma here rarely reaches the surface of the Earth. Therefore, without breaking to the surface, it pushes the different layers upwards, resulting in an elevation or dome. After some time, the magma cools down and forms rocks. The resultant elevation is known as vault or dome. High-rising domes are eroded by winds and water, forming several dome-shaped peaks called dome mountains. No tectonic movement is involved in the formation of dome mountains. These mountains often have very steep slopes. However, they do not have sharp peaks unlike other mountains. Erosion via air and water wears down the upper layers of dome mountains, revealing the cooled and solidified magma. Examples of dome mountains are the Veld in southeast England and the Black Hills of South Dakota. Let us now have a look at the fourth type of mountain known as mountains of accumulations or volcanic mountains. A volcano is a vent in the Earth's crust through which magma rises and erupts to the surface. Volcanic activities also pushes the nearby region upwards to form the volcanic mountain. Volcanic mountains, also known as mountains of accumulations, are generated by the buildup of volcanic debris. The debris is thrown out and then lands in a mountain-like shape surrounding the crater. If the lava is thin and basic in composition, it spreads across a large area, generating a flatter cone and a lower elevation and a softer slope. A small volcanic cone sharply sticking out is the consequence of it is thick and of acidic composition. Lava, ash and cinders are sometimes flung out with the lava. Ash and cinder cones are two types of volcanic cones. Lava keeps gushing out of the vent and piles up in layers, forming a rising cone-like structure. The most striking characteristic of a volcanic mountain is the crater. A crater is a circular depression formed when lava forcefully erupts to the surface. Depending upon the volcanic activity, a volcanic mountain could be active or inactive. Mount Mauna Loa in Hawaii Island, Mount Popa in Myanmar, and Fujiyama in Japan are some examples. The fifth type of mountain found on Earth is the circum-erosional relict or residual mountain. These are the remains of historic fold mountains that have been exposed due to denudation or strip of covering. Residual mountains can also form plateaus that have been carved into hills and valleys by a river. Hills such as the Nilgiri, Palkonda, Parasnath and Rajmahal, as well as mountains such as the Aravali, Vindhya and Satpura are examples of relict mountains in India. We now move on to the major classifications of mountains. Mountains are classified into numerous types based on their height, their period of origin and mode of origin. Let us take a closer look. Classification of mountains based on height. Low mountains are mountains that range between 700 to 1000 meters. Mount Shimanetop in Tennessee, US is an example. The rough mountains range between 1000 to 1500 meters. Mount Dona Buang, Australia is an excellent example. Rugged mountains generally differ from 1500 to 2000 meters. Agastya Mala in India is an example of a rugged mountain. High mountain, as the name suggests, are generally above 2000 meters. Kanchenjunga is a typical high mountain located in India. Classification on the basis of location. Coastal mountains. Things that are in the sea or on land near a coast are referred to as coastal. Coastal mountains, as the name implies, are those that are located near a coastline. The Rockies, the Appalachians, the Alpine mountain systems, the Western Ghats and the Eastern Ghats in India are some examples. Inland mountains. Inland mountains are the ones that are situated in a landlocked position. The majority of the mountains we encounter are inland mountains. Examples include Europe's Vosges and the Black Forest, Asia's Kunlun, Tian Shan, Altai ranges and Russia's Urals. Some inland mountains in India include Aravalis, Himalayas and Satpura. Oceanic mountains. The mountains located on continental shelves and ocean floors are known as oceanic mountains. Mauna Kea, 9,140 meters, would be the highest peak if measured from the ocean floor. It's a dormant volcano in Hawaii's volcanic chain. Classification on the basis of period of origin. There have been in total 9 orogenic mountain building movements taken place so far. Some happened between the 600 and 3,500 million years ago during the Precambrian period. The Caledonian, Harsanian, and the Alpine orogenies are the 3 most recent ones. Precambrian mountains. These mountains date back to the Precambrian period, which lasted more than 4 million years. The rocks have been upheaved, denuded, and metamorphosed. As a result, the remnants look like residual mountains. Laurentian mountains, Algoman mountains are a few examples among them. Caledonian mountains. Caledonian mountains developed as a result of the late Silurian and early Devonian periods. Massive mountain building process and accompanying tectonic movements approximately 430 million years and 380 million years ago. The Appalachians, Aravallis, and the Mahadev Mountains are examples. Harsanian mountains. These mountains first appeared in Europe from the Carboniferous to the Permian periods, approximately 340 million years and 225 million years ago. The Vosges and Black Forest Mountains, Altai in Asia, Tian Shan Mountains, and the Ural Mountains are a few examples. Alpine mountains. The Alps are Europe's highest and largest mountain range system, over 1,200 kilometers across 8 alpine countries of France, Switzerland, Monaco, Italy, Liechtenstein, Austria, Germany, and Slovenia. Tens of millions of years ago, the African and Eurasian tectonic plates collided, forming these mountains. It is important for us to know the significance of mountains. Mountains have an important role in supplying renewable energy to downstream cities and remote mountain communities, particularly through hydropower, solar electricity, wind power, and biogas. Mountains are known as natural water towers because they serve as crucial headwaters for many rivers and other sources of fresh water. They capture precipitation in the form of snow and ice, which gradually melts and releases water downstream. This reliable water supply supports agriculture, drinking water, and energy generation for millions of people living in lower lying areas. Biodiversity and mountains. Mountains are often hotspots of biodiversity, hosting a wide range of plants and animal species. The diverse ecosystem found in mountains contribute to global biodiversity and play a crucial role in preserving unique and endangered species. Climate regulation. Mountains play a vital role in regulating the Earth's climate. They influence weather patterns, precipitation distribution, and wind patterns. Additionally, the high altitude of mountains create different climatic zones, allowing for the existence of distinct habitat and ecosystems. Erosion control. The rugged terrain and vegetation cover of mountains help prevent soil erosion. Mountains act as natural barriers, reducing the speed and impact of water runoff, which protects fertile soil from being washed away. This preservation of soil is crucial for agriculture and maintaining ecosystem stability. Geological and scientific research. Mountains offer valuable geological information about the Earth's history, including the formation of rock layers, mineral deposits, and fossil records. Scientists study these mountains to understand tectonic processes, climate change, and ecological dynamics, providing insight into the Earth's past and present. Recreation and tourism. Mountain destinations draw tourists for a variety of reasons, including the climate, clean air, unique landscapes and fauna, visual beauty, local culture, history and heritage, and the chance to experience snow and participate in snow-based or nature-related activities and sports. Mountains attract tourists and outdoor enthusiasts who engage in various recreational activities such as hiking, skiing, climbing, and mountain biking. Mountainous regions provide opportunities for adventure, relaxation, and the appreciation of natural beauty, contributing to local economies through tourism. Cultural and spiritual significance. Mountains hold cultural and spiritual importance for many societies around the world. They are often considered sacred and are associated with myths, legends, and religious beliefs. Mountains can be pilgrimage or sources of inspiration for artists and writers. To sum up this session, we can now confidently speak about mountains, their formations, classifications, and importance. In all, mountains are crucial for biodiversity conservation, water supply, climate regulation, erosion control, cultural significance, recreation, and scientific research. Recognizing their importance is essential for their preservation and sustainable management. Thank you.